Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 2nd, 2025, so just yesterday. This paper highlights a massive challenge in robotics, pointing out that the data available for training embodied AI is only about 1/200,000th the size of the data used for large language models. The paper is titled, A Survey on Vision Language Action Models, an Action Tokenization Perspective. And it offers a really clear framework for building models that can do things in the real world. The authors unify these diverse models by looking at how they generate action tokens to interact with their environment. Also, the authors shared a GitHub repository to go along with their survey. It's not a code implementation, but rather a fantastic, awesome list of all the papers they reference. You'll find it's neatly organized, with links to foundational models and all the different action tokenization methods discussed. Okay, so the very first figure really visualizes this unified framework. At the center, you see a general model that takes in vision and language input and processes it through a series of modules to produce what the authors call action tokens. Now, an action token isn't just the final robot command. It's any intermediate guidance, like a language plan or a piece of code that helps the model decide what to do next. The diagram then shows how different existing models, like Drive VLM or Vox Poser, all fit into this same basic structure. Building on that unified framework, this next figure gives a fantastic visual for what those different action tokens actually look like in a real task. We see a robot arm being asked to pour tea. Each row visualizes a different type of action token, guiding the robot through the same steps. For example, an affordance token highlights which parts of an object are usable, like the handle of the teapot. A reasoning token is like the model's inner monologue, explaining its choices. This variety is the core point, showing how different strategies can achieve the same goal. So this next figure really puts that evolution into perspective. It's a timeline from 2017 to the present that maps out the entire field. You can see this distinct U shape, where progress on the far left, with foundational models like language foundation models or LFMs, and vision foundation models or VFMs, and progress on the far right with new datasets, supports the explosion of new research in the middle. These middle columns represent all those different action token types we just saw, showing a huge surge in new models recently. This table then details those different action token types we've been discussing. It's a fantastic overview, laying out the advantages and limitations for each one. You can see how a high-level token like a language plan is great for long-term goals, but can be ambiguous. Then you have something like a raw action, which is the direct motor command, and it's very precise, but suffers from data scarcity. This table really drives home the paper's core finding, that there's no single best approach. Instead, future models will need to combine these different tokens. So, to wrap up, the big takeaway here is that the future of these vision language action models isn't about finding one perfect action token. It's about strategically combining them. We're looking at a future with hierarchical models, using language for high-level planning, and then translating that down into precise motor commands. The authors also highlight a major shift from simple imitation learning, that is, just copying experts, to more advanced reinforcement learning, where models learn through trial and error. But the biggest hurdle remains data. That's all for today. Thanks for tuning in.